All right, welcome to IA201 Motors Controls. Oops. IA201 Motors and Controls, Chapter 1 Book Review. So Chapter 1 talks about electrical theory, which theoretically all of you have had already. Now, when I say theoretically, I recognize that sometimes individuals don't go through the courses in the same sequence, and they may have had some of this a few years ago. They may not remember all of it. So this is your chance to review and catch up if you haven't remembered all this stuff. Chapter 1 talks about electrical theory at the beginning, and they talk about theory at a particle level. So we learn about electrons and neutrons and protons, and you learn the definitions of these things. And it shows you sort of a mini diagram of what an atom looks like and the different electrons floating around that atom in different valence shells. And that's pretty cool, but not really how things work. How things really work is electrons flow like billiard balls. One electron bumps into another, bumps into another, bumps into another, and electrons don't run down the line. You know, you don't start the electricity flowing on one end and get that same electron popping out the other end. They bump into each other and they flow. The electrons flow. And when you see a positive battery terminal, a plus, that implies that stuff flows out of the plus, but it really doesn't. The battery terminal has electrons flowing out of the minus towards the plus. But when we think about electrons, we think about electricity flowing, we usually think about it flowing out of the plus. And you know what? That's just fine. It's okay to think about electricity flowing out of the plus. In fact, I'm going to give you guys my view of electricity, which many people have done before. This is not unique. Electricity is like water. Let's say you have a water tower, right? Here's my simplified version of a water tower, right? Your water is up here. And by creating this water tower, you can run a pipe down to the ground, and that pipe has pressure based on how tall that tower is. And we get into fluids, you will learn that the important part here is the density of the water and the height. The quantity of water you have up here is of no matter. The only thing that's important to create that pressure is the height and the density of the water. That height, that pressure is like voltage. You can create more pressure on an electrical wire by increasing the voltage. In fact, if you go to really high voltages, then it gets such a high pressure on that wire, then sometimes you get arcing and it jumps off of one wire and goes somewhere else. So extremely high voltage power lines, you can jump an arc 3, 4, 5, 10 feet in extremely high voltage power lines. And that's why they're so dangerous, because you can have so much pressure created by such a high voltage, it jumps, pushes through. So you think about water pressure as voltage. Then, once you get the thing flowing, if you cap this off, do I have energy flowing? No. All I have is a voltage, which I can measure, or pressure, which I can measure. In order for me to think about energy flowing, I have to have somewhere to put this water. In this case, I might open the spigot up, and then it's flowing to ground. All right, so I've given somewhere for that water to flow. And the same thing for electricity. If I have a battery sitting here by itself, 2 terminals, and this is your car battery looking down at it, just for instance, and I don't hook anything up to one wire, and I've got nowhere for that electricity to flow, there is no energy being consumed. It is simply a static system. Nothing's happening. But as soon as I hook it up to a light, still nothing happens. If I hook the other end of that light to the minus terminal or ground, then that light starts glowing. Same thing for water. It needs to have somewhere to go. In the case of water, it could just fly off the end of the hose if you've opened up that hose into ground, right? You can put a little paddle wheel here, and that paddle wheel will spin based on that water pressure. That paddle wheel is sort of an example of what a light is, right? If you spin that paddle wheel, it's like turning on that light. If I cut off the water pressure, I remove its ability to flow to ground, then that paddle wheel won't turn and my light won't turn on. So that's what I want you to think about with water pressure. You have to have water flowing through something. You have to have electricity flowing through something to create any work, to create things that require energy to happen, like lights glowing, solenoids turning on, contactors energizing, motors running, all of that. You have to have water flowing through the paddle wheel or electricity flowing through the device. So anytime throughout this course, we're going to talk about energy flowing, generally from plus to minus, which is an okay way of thinking about it, even though we know deep inside, according to the book, what's really flowing is electrons, which are a minus charge. So they're really kind of bumping each other and going in the opposite direction. Okay, so let's go on. So all of this stuff is very important. I want you to be able to read through and understand this. There will be questions in the quiz on these pages. I want you to be able to find where to look up this stuff. However, I'm going to tell you honestly, nothing in these pages is directly useful as an engineering or technician student unless you end up in the electrical engineering field. However, the basic concepts will help you diagnose problems in the future. So it's not directly useful, but basic concepts are very, very important to kind of get. Another key thing in here, in addition to understanding how electrons flow, is understanding how conductors allow for electron flow and insulators keep it from flowing. You always have insulators on the outside of your wires to keep them from grounding out or shorting. And the insulators have different characteristics that make them useful in different environments. Some of them can handle higher voltage, some of them can handle heat, some of them can handle a variety of situations that they might be abraded or abused somehow. So there's a variety of discussion about different insulators. The book also talks about semiconductors. Semiconductors is a concept we use in electronics to create our microscopic switches. They're used in a variety of semiconductor devices, and we create these semiconductors by smacking two different types of material against each other and creating unique electrical properties. The book very briefly talks about these. It's not critical that you understand these in this course, but having a basic understanding will help build a knowledge for future courses. They talk about a diode having two semiconductors, one type and another type, smacked together, and how electricity can only flow in one direction but not in the other. We talk about a cathode and anode and which end is which on different diodes. I'm not honestly sure why they stuck diodes in this portion of the book. It's really not of high value here, but it's a core electrical concept, which I guess they put all that stuff in this one chapter. The book then sort of waxes poetic about energy, some good background knowledge on different forms of energy, sources, etc. Talks about voltage as a concept. DC versus AC. Talks about current flow. which should be review for you. If it's not review, then please read through this carefully. It talks about resistance. Now, resistance is when you've got resistance in the flow. And I like to have people imagine resistance as a pinch in the pipe. So if you're thinking about energy flowing down a pipe, then resistance is a pinch in the pipe. So if you have a pinch in the pipe and I've got water flowing down this pipe, just using the water analogy, then I generally have a higher pressure ahead of the pinch than below the pinch. So I should be able to measure a pressure differential here. Call that delta P. Delta just means change in pressure or change in something. So delta P is a change in pressure. So if I put my voltmeter on a wire with a resistor on one side of the resistor versus the other, I should be able to measure a voltage difference across that resistor. And resistance is a concept that's true. Everything has resistance. Even a very good copper wire has some resistance. The longer the wire, the more resistance. And people who do any electrical engineering work know that you have to select your wire size based partially on how long that wire is. If you install commercial or residential wiring systems, you have to put a bigger wire in for longer runs so that you have less resistance. Otherwise, you're going to chew up some of your energy in resistance. The book also talks about electrical abbreviations, very useful. Talks about basic calculations using the V equals high R. Now they're using the E terminology for voltage, E. Some people use V, some people use E. It's a way of calculating the missing component. If you know the voltage and you know the current, you can calculate the resistance, and this just shows you technique for doing that. Once again, this is very much of a review. We talk about circuits. Now, circuits are where you get to some really valuable stuff. If you don't remember what a series versus a parallel circuit is, or series in parallel, then you want to review this very carefully. Now, what they show you is various math in here to calculate the resistance in various kinds of these circuits, which is useful, but not really required for this course. Just as a quick reminder, right? A series circuit is when you've got something in line with something else. That's series. A parallel circuit is when you've got something that runs in parallel to something else. So if this is a resistor and this is a resistor, those resistors are in series. This is a resistor and this is a resistor, those are in parallel. So it's kind of simplistic. There's not a lot of magic involved in figuring that stuff out. And if you have a combination of the two, then you've got a combination circuit. And if it's in series, you just add up the resistors to get the total resistance. If it's in parallel, they give you a formula for that. So this all should be reviewed. Then on page 25, we get into magnetism. Magnetism is extremely important in the mechatronics world and any world where you're using motors. Magnetism not only is important for running a motor, but it's how a lot of problems are created. When you have a magnetic pulse created by a wire, that magnetic pulse can cause problems with electronics and things like that. So understanding magnetism is very important. And so this book does that basic thing. They talk to you about how you have a north and south pole, theory of magnetism, how a wire can create a magnetic field, how if you have loops, it creates a greater field, how if you put something down the middle of those loops, it increases the field even further, depending on what the material is down the middle of the loops. And it goes through how a magnetic and current works in different kinds of circuits. And the book actually uses our water pump analogy as well. I forgot about that. Here it is in the book on page 30. So the book will take you through inductive reactance, capacitive reactance. These are all the concept of reactance. Reactance is a very important concept for AC power. And then the book gets into power. Now, I'm not highlighting anything in this section, right? Normally, I would highlight stuff which I think is especially important. All the stuff we're going through in chapter 1 is of general importance. Good background knowledge, stuff that you should have a clue about, but not necessarily be an expert in, should be stuff you've already done. Except when we get to chapter 1, page 35. Now we're diving into some stuff you may not have run into before, which is looking at power factors and looking at AC motor nameplates and figuring out some basic information about how to run that AC motor. So in this area here, I'm going to say definitely take an extra look at this section of the book. Power factors, AC motor, how to look up information on the nameplate, and how to calculate your power factor. All right. Power factor is actually an area, just to sort of divert from the book here for a second, it's extremely important for most industrial technicians today, because a big deal is to remove your overall power consumptions. And power factor has an effect on the cost of your whole business's electricity because of the additional power that's needed to fire these motors up. So you want to understand how power factor works. And that's it for chapter 1.